Hello, this video is for textbook lesson 2 of chapter 2, so it is lesson 2.2. It is titled the Distributive Property, and our objective is to use the distributive property. Our vocabulary is equivalent numerical expression and equivalent variable expressions. So we have in here an example about camping. You and a friend are going on a camping trip. You each buy a backpack that costs $90 and a sleeping bag that costs $60. What is the total cost of the camping equipment? So we need to identify the important information. We know that a backpack costs $90 and that a sleeping bag costs $60. And it says you and a friend. So there are two of you. So with that, we get some numbers in here. The value of 2 is going to come from here. Backpacks 90 and sleeping bags are 60. So example 1 says evaluating numerical expressions. You can use two methods to find the total cost of the camping equipment that's described above. Method 1 is that first you could find the cost of one backpack and one sleeping bag. So we have in the parentheses here 60 plus 90, that is the cost of a backpack and a sleeping bag. And then you can multiply the result by 2. Well, the reason we're multiplying by 2 is because, well, it's you and a friend, so there are two of you that are going camping. And that is the number of each item bought. So the total cost is equal to 2 times the quantity of a backpack and a sleeping bag. So first we add together the 90 and the 60, and that's going to give us 150. And now we need to multiply it times 2. Well, 150 times 2 is 300. Another way to do this would be method 2. And that method is to first find the cost of 2 backpacks and the cost of 2 sleeping bags, and then add those costs together. So to find the cost of 2 backpacks that are $90, we're going to do 2 times 90. And then also to do the cost of 2 sleeping bags, which cost $60 each, we're going to multiply 60 times 2. And then we'll add those together. So 2 times 90 is 180. And 2 times 60 is 120, and then we add these together to get 300. Now you'll notice that both methods produce the same result of $300 for the cost of the camping trip. And this is going to lead us to the discussion of the distributive property. In previous lessons, we talked about associative property and commutative property and the identity property, and now we're going to go ahead and talk about the distributive property. So what this tells us from example 1, it tells us that the expression 2 times the quantity of 90 plus 60 and 2 times 90 plus 2 times 60, that these are called equivalent numerical expressions. Equivalent because they're equal to one another, that is, they produce the same result whenever we calculated them. Numerical because they only have numbers in them. There's no variables involved. We didn't have any letters such as an X or an A or a Y or a Z. We only had numbers. So equivalent, numerical, and expressions because we didn't have the equal sign involved. I know we had like the equal sign here, but this right here is an expression right here, and we evaluate that. So therefore, they are equivalent numerical expressions because they have the same value. The statement 2 times the quantity of 90 plus 60 is equivalent to 2 times 90 plus 2 times 60. It illustrates the distributive property for evaluating the product of a number and a sum or difference. So whenever we talk about a sum, we're talking about adding. And whenever we talk about a difference, we're talking about subtracting. So sum is to add, difference is to subtract. And we can see right here that we have addition, and here we have subtraction. Also, they just flip it around, right? We know that we learned about the commutative property. So since A is being multiplied times B plus C, we can take B plus C and multiply it by A. We're just changing the position of the two. So these are equivalent. And then we're going to talk about the whole concept of what does it mean to distribute. So long ago, I used to deliver newspapers. And so I used to have a newspaper, and I'm trying to draw with a line. I think, let's see, let's say this is my newspaper, right? and I had the same newspaper. I had several copies of the same newspaper, and those newspapers had to go to certain houses that were on a list of houses that they gave me. So what I would do is I would drive around. I'd deliver that same newspaper to each house that I had to deliver to, and this was known as distributing. I distributed newspapers to each house. It's the same newspaper, it's just going to different houses. So with that in mind, let's take that concept of distributing, and what we're doing is A is like the newspaper. The numbers inside here that are being added or subtracted, those are like the houses that the newspaper is going to. So we have to distribute the A to the B and distribute also the A to the C. The same newspaper is going to each house. So we end up with A times B and A times C. Likewise, here, just the newspapers on the other side now has to be distributed to the B, so we get B times A, and it also has to be distributed to the C, so we get C times A. Works the same for if we're multiplying times a difference. Let me see here, difference. So the A gets multiplied times the B, and then the A gets multiplied times the C as well. And since it is subtraction, therefore we have a subtraction sign. And again, the A gets distributed to the B, B times A, and the A gets distributed to the C, C times A. And since it's subtraction, we're going to go ahead and put a subtraction sign in there. So if you kind of think about it in the concept of newspapers and houses, you kind of see why they call it the distributive property. So here we have 4 times the quantity of 6 plus 3, so it's 4 times 6, we see that there, and 4 times 3, we see that there, and it is addition, so we're using addition. Likewise, 4 times the 6 here, 4 times the 3 there, and it is addition, so we're going to keep it addition. 5 times 7, check. 5 times 2, yep. And subtraction, so we're going to use subtraction here. And then 5 times 7, yep. And 5 times 2, right there. And it is subtraction, so we're going to use subtraction here as well. So that's the concept of the distributive property, that the number that's being multiplied times whatever the plus or minus is going on inside of the parentheses, we're just distributing that value in. So up here in our reading algebra of our vocabulary, when you use the distributive property, you distribute the number outside the parentheses to each number inside the parentheses. So just like the newspaper going to the houses, A times the B and A times the C, and since this one's addition, we have addition between the two. So let's look at our next example using the distributive property. We're going to use the distributive property to demonstrate what our mental math would look like for finding the cost of some geodes. A geode is a hollow rock whose interior is lined with crystals. Many geodes are small enough to fit in your hand, but a giant geode in Spain, it's 26 feet long and it can hold 10 people inside. Wow. How does this geode's length compare with the length of your hand? So right now we're going to talk about the cost of the geode, so much not trying to figure out the question that they're asking here. So geodes. After touring a cave, you visit the gift shop and buy 3 geodes. Each geode costs $5.95. Use the distributive property and mental math to find the total cost of the geodes. So total cost is going to be 3 times the cost of each geode, which is $5.95. Now we're going to rewrite $5.95 as $6 minus 5 cents. All right, looks like 0.05. That's like a nickel. So now we're going to rewrite this using the distributive property. The 3 is going to get distributed into the 6, and we have 3 times 6. The 3 also gets distributed to the 0.05, or you might say the nickel. Right there we have that, 3 times that, and it's subtraction, so between the two of them. So we're going to put subtraction here between these two as well. All right, so we've got that written out. Now, 3 times 6, well, that's 18. And 3 times 0.05, well, think of this as a nickel, right? 3 nickels is 15 cents. So we end up with minus 15 cents. Now $18 minus 15 cents is going to give us a total of $17.85. Think of the 15 cents as 10 cents plus 5 cents, right? 18 minus 10 cents would be $17.90. Take off another nickel, we'd be at $17.85. So the total cost of the geodes is $17.85. Let's look at our checkpoint here. We're going to use distributive property to evaluate the expression. So on number 1, we have 3 times 8 plus 5. We can rewrite this as 3 times the 8, 3 times 8, and not 80, but 3 times 8. And we're going to use a plus sign because that's what's inside the parentheses there, times 3 times 5. And I want the 3 first. 3 times 5. Now 3 times 8 is 24, and 3 times 5 is 15, and 24 plus 15, think of this as 10 plus 5, right? So 24, 34, add 5 more is 39. So this one here would equal 39. Let's squeeze in another one from number 3. Let's do 6 times the quantity of 11 minus 4. So let's distribute the 6 into the 11 and have 6 times 11. And that's going to be subtraction because we have subtraction inside the parentheses. And 6 times the 4. So 6 times 11 is 66. Minus 6 times 4 is 24. So now 6 minus 24. Well, let's think of 24 is 20 plus 4. 66 minus 20 is 46. Minus 4 more is 42. So this one here would equal 42. And let's go ahead and do number 4. And I don't like the number that's being multiplied on the back side. Let's go ahead and just use that commutative property, and let's go ahead and flip those around. Commutative property of multiplication. So I'm going to have the negative 5 multiplied times 3 minus 14. Now I'm going to do negative 5 times the 3, and I'm going to subtract from that that would be negative 5 times the 14, and negative 5 times 3 is going to be negative 15, minus, and negative 5 times, another parenthesis there, I guess, negative 5 times 14 is going to be, I'm going to think of this as 5 times 14. I'm thinking that is 10 plus 4. So 5 times the 10 is 50. 5 times 4 is 20. And so this is going to equal 70. So that's negative 70, right? Negative 70. Now, we've done this before with adding and subtracting integers. I don't like this minus a minus. So I'm going to do negative 15. Going to change the sign to addition, take the opposite of negative 70, which is positive 70. Now I know that they are indeed two opposite signs. One's negative, one's positive, and I am adding them. So I can actually subtract 70 minus 15 and get, what is that, 70 at, no, what I'm doing mentally is I'm doing 70 minus 15, and I'm thinking of 15 as 10 plus 5. So 70 minus 10 is going to be 60, minus 5 more is going to give me 55. So my answer would be 55, and the 70 has a greater absolute value than the negative 15, so the positive is going to win out, so my answer is a positive 55. Now, I could double check my answer because all of this here have these negative signs. I might want to make sure. So 3 minus 14, if I had 3 minus 14, let's think of that as 3 plus negative 14. And they are different signs, so I'm actually going to subtract 14 minus 3 is 11. And the negative 14 has a greater absolute value than the 3. So my answer is going to be negative. So I would end up with, let's go ahead and erase this so I can fit that in. What's inside the parentheses would be negative 11, right? And then negative times negative, because I'm multiplying what's inside the parentheses, negative 11 times negative 5. So negative times negative is positive. That works out. And 11 times 5 is 55. So positive 55 would be correct. Let's go ahead and erase all of this here. Not what I wanted to do. There we go. I want to erase just the writing. Now let's do some of the using distributive property and mental math. Now, I could do it mentally, but if I do it mentally, you can't see my thought process. So I'll go ahead and write this out. Let's go ahead and represent this 105 as 4 times the quantity. I'm going to rewrite 105 as, let's see, I think 100 plus 5 would work really well. Now I can think of this as 4 times 100 plus, so 4 times the 100, now 4 times 5, 4 times the 5. Now 4 times 100 is 400, and 4 times 5 is 20. And so my answer would be 420. Next one, let's see, we'll do number 6 right here. 3 times 97. Let's think of 97 as 100 minus 3. That's going to help us out because we'd have 3 times the 100. And then we have a minus sign, so we want to put minus there. 3 times 3. So I've distributed the 3 into the 100 and to the 3. 3 times 100 is 300. Minus 3 times 3 is 9. And 300 minus 9 is going to give me what? 291, right? So that would be 291. Looking at the next two questions, 7 and 9, let's think of 2.9. Let's rewrite 2.9 as 3 minus 0.1. So if I took 3 minus 0.1, I would end up with 2.9. So now let's go ahead and rewrite this as 5 times 3, distributing the 5 into the 3, and now multiply the 5 times 0.1, and that is subtraction, so I'll put my subtraction sign there. I end up with 15 minus 5 times 0.1 is going to be 0.5. So think of this as like a nickel, $15 minus 5 cents. So I'm going to end up with $14.95. So 14.95 would be our answer for that one. And then for 8 times 7.02. Well, let's rewrite 7.02 is 7 plus 0.02. Just put a 0 in there in front of it. So 8 times 7 is going to be, okay, let's go ahead and write that 8 times 7. And then we also have 8 times the 0.02, 0.02. And this is addition. Now 8 times 7 is 56. And 8 times 0.2, that's like, think of that as 2 pennies, right? So that would be 0.16. 8 times 2 cents would be 16 cents, so we'll list that as 0.16. And so this is 56.16. So these are illustrations and examples of how we can use the distributive property to help with mental math. Two variable expressions that have the same value for all values of the variables are called equivalent variable expressions. So we've talked about equivalent numerical expressions. Now we're talking about equivalent variable expressions. The only difference is this time, the others, if we look back at it, we only had numbers in it, right? Over here, these are all equivalent numerical expressions. There's no variable there, so they are numerical expressions and they are equivalent. However, as we go forward here and look, we're now dealing with expressions that have variables and they are equivalent to one another. You can use the distributive property to write equivalent variable expressions. So use the distributive property to write an equivalent variable expression. So we go from 3 times the quantity of x plus 7. So 3 times the x is 3x. 3 times the 7 is 3 times 7. It is addition, so we leave it as addition. So we end up with 3x. 3 times x is 3x. And 3 times 7 is 21. So we could rewrite this as this. And we use the distributive property to do so. On the next one, we have the negative 2 times n. So we have n times negative 2. And negative 2 times 4 we have here. It is addition, so we leave it as addition. So we have n times negative 2. We end up with negative 2n. We wouldn't want to write n negative 2. Then it would look like n minus 2. And the number out in front of a variable is called its coefficient. And we refer to it as, we like to have leading coefficients. And by leading, we mean that they come before the variable. So we would want to write this as negative 2n, not n negative 2. And then 4 times negative 2 is negative 8. And we do have the addition, so we leave that there. Now we could simplify this just a little bit more. Instead of having plus and negative, we could just do minus a positive. So we bring down our negative 2n. And we change the sign from addition to subtraction, and then change the negative 8, take the opposite of negative 8 to positive 8. So we end up with negative 2n minus 8, and we got that from the statement here. Finally, we have negative 5 times the quantity of 2y minus 3. So we have negative 5 times 2y. We see that right here. Negative 5 times 3, we have that right here, and it is subtraction, so we leave it as subtraction. Negative 5 times 2 is negative 10, and the y goes along for the ride, so negative 5 times 2y is negative 10y, and negative 5 times 3 is negative 15. We bring down our subtraction sign, and then we can simplify this a little further. Instead of a minus and negative, we're going to change the sign to addition. Take the opposite of negative 15, which is positive 15, and finally we would get the equivalent expression, or the equivalent variable expression, because it has a variable in it, the y, of negative 10y plus 15. So in our checkpoint here, whenever we look at this here, we go ahead and we do 8 times the x and 8 times 2, so we end up with 8x and 8 plus, and I'll go ahead and write this out, 8 times the 2, and we could simplify that a little further to 8x plus, well, 8 times 2 is 16. On the next one, we have the negative 4 times the 7, so we have negative 4 times 7, and we also have the negative 4 times t, negative 4 times the t, and it is a subtraction sign here, so we'll leave a subtraction sign there. So negative 4 times positive 7 is going to be negative 28 minus, and then we have negative 4t times t is going to be negative 4t. Now we have a minus, so we could do negative 28, change the sign to addition, take the opposite of negative 4t, which would be positive 4t. And personally, I think I'd rather flip these around. I would probably use the commutative property here. I like to have my variables over here before the ones without variables. So I take that 4t, put it over here, and it is plus, and then negative 28. Now I do have the whole plus and negative here. If I wanted to, I could simplify this even further. Put 4t, change the sign from addition to subtraction, take the opposite of negative 28, which would be positive 28, and that would be simplified there. And then let's go ahead and do number 12 over here. Negative 2 distributed into the 6y, so that's going to be negative 2 times 6y. And then I also have the negative 2, and I'm going to multiply that times the 4 over here. So that's going to be 4. And it is subtraction, so I'll put a subtraction sign there. Now, negative 2 times 6 is going to be negative 12, and the y goes along for the ride. Bring that y down. Put our minus sign there. And then 2 times negative 4 is going to be negative 8. And now I do have minus and negative, so I can simplify this even further. Let's bring down the 12y, change the subtraction to addition. The opposite of negative 8 is going to be a positive 8, and so I could simplify that to negative 12y plus 8. Now, we can use the distributive property. It's useful for calculating things like the area of geometric figures. So it says find the area of a rectangle or triangle. So the first one, we're given a triangle. It has a length of 2x plus 5, and it has a width of 7. So use the formula for area of a rectangle. Well, the formula for the area of a rectangle is angle times length times width. So we're going to take this length here, and we put it right here, and then we won't need to multiply it times the width, which is 7. So now we're going to distribute that 7 into the 2x. We get right there. Distribute the 7 to the 5. We get right there. 2 times 7 is 14. The x goes along for the ride. And 5 times 7 is 35. So we could simplify this area of a rectangle down to 14x plus 35. So the area is 14x plus 35 square units. On the rectangle, let's use the formula for the area of a rectangle. Well, the area of a rectangle is equal to 1/2. B is for base, h is for height. So the base is 12. So we're going to bring that 1/2 over. Here's 1/2. We're going to substitute in the value of 12 for the base, and for the height is 8 minus 3. So we're going to go ahead first. Let's simplify this 1/2 times 12. Well, 1/2 of 12 is 6. And then we're going to bring down the 8 minus 3y. Next, we need to go ahead and use the distributive property because we're all set up for distributive property here now. 6 times the 8 we have there. 6 times negative 3, or 6 times 3y is here. And we bring down that subtraction sign that we have there. 6 times 8 is 48. 6 times 3 is 18. The y goes along for the ride. And subtraction stays, so we have minus. So the area for this triangle here is 48 minus 18y square units. If you really wanted to, you could. If you wanted, you could put that 18y. This is actually, that would get tricky. It'd make it negative. We don't want a negative number out front. So we'll do that in another lesson. All right. So guided practice. What property is illustrated by the statement 3 times the quantity of 4 minus 9 equals 3 times 4 minus 3 times 9? This is the distributive property. We can see that we've distributed the 3 to the 4 and the 3 to the 9, and it is subtraction, and we've kept it subtraction. So this is indeed the distributive property. Are 2 times the quantity of x plus 1 and 2x plus 1 equivalent variable expressions? Well, let's see. If we did 2 times the x, we would end up with 2x, and 2 times 1 is 2, and we have a plus sign, so it should be 2x plus 2. Well, they say 2x plus 1. So what happened is, if you were to do this, you could only get that by not distributing the x to both of them, only to the 2x. In order for this to be 1, you would have had to have failed delivering or distributing the 2 to the 1 as well. So the answer is no, and that's because the 2 was not distributed to both values. Evaluate the expression, use the distributive property in mental math. Let's say this one here, we could say 6 times, think of 100 is 100 plus 3. So 6 times 100 is 600. And 6 times 3 is 18. And we'd have to add those together, and that would equal 618. That would be our mental math for that one. And for this one here, the number 5, let's do number 5 off to the side here. So 2 times 8.95. 2 times 8.95. So we probably would do well if we would think of 8.95 as 9 minus 0.05, like a nickel. So let's do 2 times 9. And that's there. And 2 times the 0.05. So 2 times 0.05. Distributed the 2 to both of them. This is subtraction, so we'll go ahead and leave that there. 2 times 9 is 18. 2 times 0.05, well, that's like 2 nickels, right? So that would be 0.10, like a dime. and we're subtracting. So $18 minus 10 cents would be $17.90. So 17.90. And for the sake of time, let's go ahead and jump to, let's do number 10 right here. Use distributive property to write and evaluate variable expressions. So let's do the -4 times the 2n. So -4 times 2n. And let's do -4 times 7. So -4 times 7. And this is subtraction here. We don't want to mix in that negative with that subtraction sign. -4 times 2 is -8, and the n goes along for the ride. We do have a minus sign, and then -4 times 7 is going to be -28. Now we have a minus, so we could do this -8n, change the subtraction to addition, and take the opposite of -28, which is +28, and we would end up with, this simplifies to -8n plus 28. And then the game room question, we would get that from applying formulas like we did in example 4 here. So that completes all of my instruction for lesson 2.2, titled The Distributive Property, where we learned to use the distributive property. Thank you.